Hello and welcome. This video is going to be a showcase of an application I made for a programming class I had last semester. It's supposed to be a clone of Conway's Game of Life. If you haven't heard of it, I'll go over a quick explanation in just a moment, but don't expect too much details. You will have to do some research of your own, as this is just a showcase of the program itself. So here is the start menu. You can choose the X and Y dimensions of the grid that will be in the Game of Life. The limit is from 0 to 20. So we can take, let's say, 8, 10, and 8. And as you can see, this is the grid that we get. Now we have a few buttons here. We have the reset that resets the grid, random that fills it with randomly. The chance of filling one is 1/3, I think, so 33%. We have an auto button that automatically plays the simulation, and we have a menu to go back to the main menu. All right, so to quickly explain just what Game of Life is all about, it's essentially a simulation where there's a set of rules that each tile has to follow in order to either be alive or not alive in the next generation. So the rules for a tile to be born in the next generation is that it needs to have 3 neighboring tiles that are alive. So for example, this tile right here, it will be alive in the next generation because it has 3 neighbors right here. The rules for a tile that already is alive, though, to stay alive in the next generation is slightly different. Is it needs to have 2 or 3 neighboring tiles that are alive. Let's take this configuration as an example. We have this tile in the top left corner is going to stay alive because it has 2 neighbors that are alive. This top right corner is also going to stay alive because it has 2 neighbors, this one and this one. And the same goes for the last corner. It will stay alive because it has 2 neighbors. And this tile right here, it will be born in the next generation because there are 3 neighboring tiles that are alive. So let's just play it on auto. As you can see, the settings are here are to play 1 generation every 1000 milliseconds. So as you can say, it was born in the next generation, and you might wonder, why is nothing happening? Well, if we look at the rules of the game again, we can see that this is the way it's supposed to be because each of these tiles has 3 neighbors, and there is no tile around it that has exactly 3 tiles, which it needs in order to be born in the next generation. So let's take a different example. Like this one. This is what's called a blinker, I think. It works slightly differently than the thing we looked at earlier because it doesn't get stuck in a certain configuration. This one will keep repeating forever, as you can see. And this is pretty obvious if you think about the rules of why this happens is because this tile and this tile, it will always have 3 neighbors, so it will always be born in the next generation. And if we go to the next one, you can see here, oh, well, if we switch then here and here, these have 3 neighboring tiles that are alive. Now, why do the tiles that are up and down here, why do they die? Well, they only have 1 neighbor that is alive. The one in the middle, however, has 2, so it will stay alive. All right. Of course, we can change the timer for it to go faster. There are a lot of interesting configurations you can come up with. There are a few other. This blinker here that I showed you, this is called a blinker. It's a type of oscillator, what's called in this Game of Life context. There are others as well. For example, this one. It will keep blinking because as you can see in this position, it has 3 neighbors, so it will be born here, and this will be born here as well because it has 3 neighbors. And in this situation, it has 4 neighbors. and this one has 4 neighbors, so it will die because it has too many neighbors. It has to be exactly 2 or 3 neighbors in order to be born in the next generation. Yeah, it's pretty interesting application to mess around with. There are a lot of what's called a still life. That there is essentially a configuration that gets stuck and it never does anything. So let's say this one, it will always be stuck like this. This one will always be stuck like this. Other different one. There are a lot of them. Let's make a bigger board, grid rather. Let's make it 20. That's the maximum size. You can see it's pretty big. And pick it at random, and then make it like 1 millisecond. It says 1 millisecond, but it's not quite true because it will just go as fast as it can. So it's essentially as fast as it can, like 1 frame. You can see here, and it's interesting to see what the pattern ends up as. It's obviously random, and it ended up as 1 oscillator. The cool thing is that the game of life, it works in this way that it will always end up like one of these. It will not go on for infinity. It will always go back to some kind of like either one of these or some sort of oscillator with some weird some type of period. Like this has a period of 2. It repeats every 2 frames. Let's say there are other oscillators that blink, like they repeat themselves every 3 generations. And there are also what's called a spaceship, something that's independent, like you could call it, I suppose. For example, this thing right here, it will keep moving like this, and it will never stop moving because of the rules of the game. And what's interesting is that it repeats itself every 4 generations. So if you put it like this, it will just essentially just see it moving like that. Yeah, and that's called a glider, I think. Yeah, there's a lot of cool stuff. A lot of, I mean, it's a simulator, so there's only that much that you can do. There's a lot of cool stuff that people have come up with in this program. I recommend for you to check it out if you're interested. The easiest way to get into it is look at the Wikipedia page for Conway's Game of Life. But that's about it for this showcase. I think I've covered everything. Obviously, these buttons are self-explanatory. This is a toggle button, and the menu just takes you back to the menu. If you put in nothing, the application will still work, but nothing will happen. But okay, I think that's everything I had to show. And I think that's about it. I was originally not going to make a showcase. I was originally going to do a tutorial on how to create this application, like a longer series, a few episodes probably. But I was thinking I'd do the showcase first and see if people are interested at all. Then I'll probably go ahead and do it if there's enough interest. But yeah, that's about it. So thanks for watching, and do leave a comment if you're interested in a tutorial for it. Either an extended one or just a short one for the algorithm behind the program. Yeah, that's it. See ya.